So exosomes are teeny tiny little bubbles. They're all bubbles, but
Yeah.
with a phospholipid bilayer. But that is, 50 to 150 nanometers. That's invisible with light. So one thing is the size. The reason humans conflate stem cells and exosomes because they're both getting them from their doctor who says it's going to cure their arthritis, right?
Mhm.
But the point of fact is that they're totally different. It's like what's the difference between a musician and a song? A song is a collection of notes that's played by the musician. So musicians or cells are gigantic. They're, 2,000 to 20,000 nanometers. They have machinery, they have DNA, they live, they breathe, they have energy. These are just passive little messages in or songs in these little bubbles.
Welcome to The Functional Edge. I'm Dr. Julia Ward, and this is where science meets real-world strategies for living healthier, sharper, and stronger. From uncovering hidden environmental toxins to unlocking peak performance and mental clarity, we cover it all. Ready to take control of your health and thrive? Let's dive in. Welcome to the Functional Edge podcast. I'm your host, Dr. Julia Ward, medical director and founder of Balanced Body Functional Medicine. Today, we're honored to welcome Dr. Ed Park to our show. In this episode, Dr. Park will be sharing his insights on exosomes and telomeres, offering expert guidance to help you navigate your health journey with the latest advancements in functional medicine. Stay tuned for an engaging conversation that promises to empower and inspire your path to wellness. Dr. Park, thank you so much for being here. I'm going to let you introduce yourself a little bit more.
Okay. Thanks, Dr. Ward. I appreciate it. Yeah, I'm just sitting here in my apartment in LA. And for the last 6 years, I've been doing exosomes, which is a stem cell product. And it gets your body to start thinking it's healing like a newborn. So that's had some really interesting results. Prior to that, for 17 years, I've been taking a telomerase activator. And so we can talk about what that means, but it's kept me relatively okay. I don't need reading glasses. I can read this close at 57 and not much gray hair up top. So that's kind of cool. So those are the main foci of what I'm doing. I grew up like you in Southern California. I guess you spent some time in OC,
Yeah.
as did I. And then I went 12 years to the East Coast as an undergraduate at Harvard, then Columbia for my master's in public health and MD, and then back to Harvard for an OB-GYN in residency OB-GYN. And I did that for 17 years before I got on board with telomerase activation and regenerative medicine, and now last 6 years, exosomes.
That's great. That's great. Well, let's start at the beginning. What exactly are telomeres and exosomes? And especially for our audience who may not be familiar with both, can you just give us sort of a basic definition of both?
Yeah. So telomeres, at the end of every chromosome, since they're linear chromosomes, they have a cap, which is like a firecracker fuse. And so because of the mechanics of DNA copying, like it does a really good job. It only makes one error in 7 billion base pairs, I think, every 3 divisions. So it's very, very accurate. But the ends, the way that the mechanics work, you can't copy to the very ends. So every time a cell divides into 2, you lose 50 to 100 of these little base pairs or, whatever, DNA. So for certain types of cells called stem cells, they can translate, turn on an enzyme that will reverse transcriptase. And that means that it'll re-lengthen the ends, gives you more firecracker fuse so that firecracker don't blow. So if you just leave cells in a dish and you let them copy, 50 to 70 divisions later, they're dead because all the ends get sticky and then the chromosomes get ripped apart. And that's the end of the line, figuratively and literally, for that cell.
Right. Okay. So those are telomeres.
It's just the firecracker fuse on the end. That's why, my first book was Telomere Time Bombs. They're like little time bombs. So as we go through life, all the copying in regular cells and in stem cells causes what we show up as, aging, wrinkles, heart disease, high blood pressure, Alzheimer's, macular degeneration, etc.
Right. And exosomes, what exactly are exosomes?
Now, exosomes have been seen. I mean, they invented the electron microscope 90 years ago, but once in a while they'd see these little outpouchings, these buddings off the cell, and in them maybe, 10 to 30 little bubbles. But you can't see them with the optic microscope, only electron microscope. And they just agreed to call them poop. There were some immunologists that were onto it. Maybe it's not just poop, but everyone just agreed to agree.
Okay.
And then about 17 to 18 years ago, someone said, well, what if they're not? And so they took the extra step of melting the little tiny spheres. They're, 40 to 150 nanometers, literally invisible. And they're like, oh my God, there's all kinds of mRNA, microRNA, some proteins. These are communication. So
Yeah.
they've been playing catch up. Like the annual International Extracellular Vesicle Conference is only 13 years old. I'm going to Vienna next month. And people are always saying, oh, we were so wrong about this, that, and the other thing. So
Yeah.
the short answer is nobody knows. But it looks like in plants and animals, this is how cells communicate. And that can have really serious repercussions, you know.
Right. Right. Well, what led you to get into this area of regenerative medicine?
Yeah. So, you know, the telomeres I've been taking personally for 17 years, and people can learn about that. And I just did a video about my 17 years. So it seems to have kept me aging slower. The exosomes, I had a fan who wanted to create an anti-aging company, and I brought in another scientist, translational medicine MD. So we were working on ways to commercialize exosomes for anti-aging. And then 6 years ago, I went to a lecture at A4M, American Academy of Anti-Aging Medicine.
Hmm.
And there was a neurologist who I currently work a lot with who talked about his motorcycle accident. And at that time, he was 67. He broke 9 ribs, collarbone, ankle, lost a third of his blood. And he was up there laughing and giving a lecture 6 weeks later. And I thought that was remarkable. And
Yeah.
so he confessed that he gave himself exosomes and he healed at a, you know, preternaturally rapid rate. So I
Wow.
said, oh, okay, well, it's worth a shot. And I had dinner with the founder of the company.
Yeah.
This guy seems legit. He's very open. He's very honest. He's very meticulous about the science. So I injected my Achilles, my meniscus, and my rotator cuff, and boom, all good. I've had to
Wow.
do the Achilles and rotator a couple times since in the last 6
Uh-huh.
years, but the knee was one and done in my case. So it was
Wow.
clicking and hurting. So I'm like,
Wow.
wow, this might work. So I got some extra training in ultrasound guided procedures,
Yeah.
got the malpractice insurance, started testing on friends, family, close patients, and yeah,
Yeah.
that's where we're
Wow.
at.
And when you say you're taking telomeres, you were taking the supplement that helps to keep your telomeres
That's right.
long,
It's called the
right?
Telomerase activator, TA65. It's been
Hmm.
out since 2007, and I've been taking it every night for 17 years.
Okay.
And up until last year, when my mom talked me into taking DHEA,
Uh-huh.
that's really all I've taken for 17 years straight. And
Oh, wow.
knock
Okay.
wood, I stayed away from the doctor, even the dentist, and trying to keep it that way, you know.
Yeah. Yeah. What's the mechanism behind how telomeres shorten, and what does this mean for aging?
Yeah. So it's just, you know, there's nobody worth their salt that would dispute what I'm saying. It just,
Hmm.
when a cell needs to copy all the chromosome library, it has something called an RNA primer, which is where the, you know, thing locks onto the existing DNA to create the copy of the DNA. So
Okay.
that just can't make it to the very tippy tip or the end. So you lose 50 to 100 base pairs. And that's the mechanism. Anytime a cell divides into two, you're going to lose telomeres. And that there's a guy named Leonard Hayflick who died a few years ago who figured out that, you know, cells in culture, they can only divide so many times. That's the Hayflick limit. Whereas, you know, chicken stem cell from the heart of the chicken, it can live indefinitely because they have telomerase constitutively turned on.
Ah,
So that's just what it is. A stem cell, for those that don't know, is defined by two things: telomerase activation, meaning the ability to re-lengthen this fuse, this clock,
yeah.
and asymmetric division, which is the ability to stay one perfect mom and one specialized daughter. That's basically a working
Okay.
definition of stemness. So there's different things I wrote about in this book for Hay House. I don't even remember reading or writing a single paragraph, but there's, you know, 6 things what we do. I'm sure there's more, but like sleep, diet, exercise, food, your state of mind, etc. And studies have shown, I mean, they're not great studies, but they do show that, hey, if you sleep really great, your telomeres are longer.
Mhm.
Telomerase active. So it is the bad habits, you know, that cause us to not heal as efficiently. So telomerase isn't on all the time, otherwise we'd have really, really long telomeres and that would be inefficient. But if you want to keep aging at a slower rate, you want to do things that are good for telomerase activity. And, you
Right.
know, on a meta level, when you look at animals that have high telomerase activity and even trees, they tend to live longer, which is
Oh,
interesting.
yeah.
Yeah.
Can telomere length be measured accurately in clinical practice? And so, how do you test for it? And what do you consider a clinically meaningful result?
I mean, that's a tough question. I used to measure my telomeres every year for years and years with 4 different labs, and there's
Okay.
different methodologies. And so there's a video on this measuring telomeres on YouTube channel, DRPARK65. The
Okay.
short answer is yes, you can measure them. But what I found in practice was that when I sent the same person, same blood, same time to 4 different labs,
Hmm.
they'd come back with numbers like 7, 9, 11, 13,000. So year over year, their methodologies were consistent. But there, it's like if I said to you, oh, it looks like you weigh about 70 pounds, 90 pounds, 100 pounds, or 130 pounds, you wouldn't think that was a very accurate measurement, right?
Right, right.
So there, we can get into the nitty gritty. I'm sure people don't care, but there's PCR, quantitative PCR. There's Flowfish. You know, I think the Flowfish was the best, but unfortunately, the company I was using got rid of their measurement of critically short telomeres, which I think is the most interesting. But yeah, people do it. I'm not sure how accurate it is. They use it. It's not nearly as accurate as epigenetic testing, which has an R-squared correlation of like 95%.
Hmm.
But again, it's debatable as to what that means too.
Okay. Are there validated ways to preserve or even lengthen telomeres? And how do lifestyle supplementation or medical therapies factor into this?
Well, lifestyle, I talk about in the book, The Telomere Miracle. Medical, it's if we're being completely honest, the molecule is like a steroid molecule. And so, A, B, C, D chain. Steroids are like what? Estrogen, testosterone, progesterone, DHEA. They did extract it strangely from a plant. Astragalus was an ancient Chinese longevity herb, and they may or may not be modifying it in a way to increase the potency. So the evidence is scientific. It does show transient telomerase activity. There may be some that do even a better job. I'm not sure about their safety. But yeah, this is not like, crazy like nonsense. There are about 7, 8 studies. I'm going to interview Joe Raphael, who's done those clinical studies, showing in randomized controlled trials that it does improve outcomes, especially vis-a-vis immune senescence, which is really where the rubber meets the road.
Right.
So if you dial it back and talk about this Dutch lady that died like 7 years ago, her name was Heinrike van Wandelschlepper. You and I have thousands of hematopoietic stem cell variants because we got a lot of blank keys. We can respond to different threats, internal and external. By the time she reached like 114 or whatever, she only had 2 left. And that tells us that in the game of musical chairs, she won, but we're
Mhm.
all losers because as life goes on, we lose stem cells from
Mhm.
telomere attrition. And that's really my theory about why we get old. It's not really even a theory, it's kind of common sense.
Yeah.
So,
And that Dutch lady was the oldest living person around. I think she was 115, right?
yeah, she made it. I had a lady who made it to 114. I'll tell you what,
Wow.
she was taking telomerase activators
Uh-huh.
and she grew hundreds of black hairs, which is
Wow.
remarkable.
Wow. Okay. Getting back to exosomes, how do they differ from stem cells? There's
Yeah.
seems to be a lot of confusion around exosomes. Maybe you
Mm.
can clarify their role in cell communication and healing.
I mean, the best way I could say is like an analogy. So the cover of my book shows Exosome Songs of Healing.
Hmm.
So my illustrator I've worked with for 15 years or more, she couldn't really get it right, but that's okay. It's pretty close. So this pink thing is a giant cell. So that's like, anywhere from like 2 to 10 microns or, 2,000 to 20,000 micron or nanometers.
Uh-huh.
So exosomes are teeny tiny little bubbles. They're all bubbles, but
Yeah.
with a phospholipid bilayer, but that is, 50 to 150 nanometers. That's invisible with light. So one thing is the size. The reason humans conflate stem cells and exosomes because they're both getting them from their doctor who says it's going to cure their arthritis, right?
Mhm.
But the point of fact is that they're totally different. It's like what's the difference between a musician and a song? A song is a collection of notes that's played by the musician. So musicians or cells are gigantic. They're, 2,000 to 20,000 nanometers. They have machinery, they have DNA, they live, they breathe, they have energy. These are just passive little messages in or songs in these little bubbles.
Okay. How do exosomes work when they're administered therapeutically? Like what's happening at a cellular level when somebody receives exosomes?
I mean, that's a great question. Again, in Vienna next month, they're going to say, we don't know. They always flex or lead with the fact that I was such an idiot. I was publishing nonsense for X number of years. And the longer you were publishing the wrong answer, the more credible you are. So it's really kind of like a bizarro conference, but there's a lot that we don't know. And so the short answer is that it is likely because, a phospholipid bilayer is fat on the outside,
Hmm.
protein tail in the middle, usually. or actually the phospholipid is hydrophobic and then hydrophilic and then hydrophilic and then hydrophobic. So this phospholipid bilayer this is how everything works: cells, membranes, and exosomes. So it is likely there are other mechanisms of binding, like to clathrin-coated pits and whatnot, but it's likely that they can just touch a cell and become incorporated, like a bubble. You touch another soap bubble and just get incorporated. And in doing so, it'll inject the RNA, which is a message to encode a protein. So right away, that's how Pfizer and Moderna got us to make spike protein, because these little artificial exosomes bound to our cells, and our DNA couldn't help but produce the message that they wanted to produce. But interesting, I just interviewed the founder of the first exosome company. He said that actually the microRNA predominates. So let's talk about what microRNA is. RNA is just a single strand nucleotide sequence, right?
Mm-hmm.
So the longer proteins have longer sequences. But the microRNA, I think it's 22, 23 base pairs. It's a specific antisense thing. So what it really does is it stops the expression. Let's say you have a RNA sequence that makes VEGF or something, or some protein. The microRNA has a specific code, ACTG, blah, 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 that is antisense to that VEGF messenger. So if it gets in there, it sticks to it, and the ribosomes can't run down the line, and it just blocks it. So a lot of the behaviors, whether it be dedifferentiation or cell signaling, are because the microRNA is stopping something
Okay.
from being expressed, which is fascinating.
Who might be a good candidate for exosome therapy?
I mean, in point of fact, we're all using exosomes all the time, every day, cradle to grave. I mean, if you get a paper cut or get hit by a Mack truck, your body's going to pump out exosomes to try and heal.
Yeah.
The game changer is that we have old cells and they respond a little less well.
Mm-hmm.
If you play, chubby checker or in the mood to a, 60-year-old or an 80-year-old, they might want to dance, but their cells can't dance, right? But this comes from a newborn baby placenta stem cell. So the quantity and the potency is much higher from a newborn. Even though
Yeah.
it's an adult cell, you just get a higher payload. So that's why, it's even harder to bounce back from injury when you're older. So we see amazing things. And that's the origin story that Duncan talked about, is that when he was trying to grow an old lady, a 70-year-old lady's cells, they wouldn't copy. But he took some of the serum from the 18-year-old paraplegic's cell culture and put it in the old ladies, and you got those cells dividing.
Oh.
So the quality of the signals matters. So you're just triggering your body to heal like a newborn if it can.
Are there specific conditions that you've seen consistent benefits?
Yeah, I mean, we've seen across the board, not everyone. I never go to someone who says everyone gets better, I have no failures.
Yeah.
A lot of that depends on the terrain, as the naturopaths say. So it depends on your age, your attitude, what else is going on, immune suppressants, things like that. But
Yeah.
in general, we get like a 70% response rate of improvement. So that's across the board,
Yeah.
because your body still has that latent ability to heal, either by copying or dedifferentiating or changing the immune expression. So to answer your question a little more directly, people seem to do well with a lot of aches and pains, whether they be musculoskeletal, joint related,
Mm-hmm.
autoimmune, even leaky gut, some brain fog. We
Yeah.
can't say because of FDA and state med board that we're curing disease,
Right.
but oftentimes people are quite happy. And the majority of my referrals are actually people referring themselves,
Yeah.
because you help them with their shoulder and they say, oh, come back to Houston and do my knees.
Yeah.
So,
Yeah. And how is exosome therapy administered, and how do you measure whether it's working?
well, it's important that I stress it's not FDA approved yet. There are about over 12 trials going through the FDA. So just like a person who gets paid money to put epidural steroids in your back, that's not FDA approved, but it's standard of care
Mm-hmm.
and it is reimbursed. So
Mm-hmm.
this is not reimbursed by insurance now. It's not FDA approved to treat or prevent any disease. And having said that, all my patients read and sign and I hope understand that that's the case. If they do understand that and they're willing to have good communication with me, we can use it in a variety of different ways, both topically and, parentally and enterally, and
Mm-hmm.
usually not enterally. That means
Yes.
swallowing. But I have
Wow.
done that for esophagitis and peptic ulcer. But yeah, they can do it in a lot of ways. There's a lot of ways that the body likes them. And they're so small that you could probably absorb them through your skin. But we do microneedling. and we do hair.
Yeah.
And so, yeah, they're so tiny. They can really get in, even from the blood into the brain through the blood-brain barrier.
Yeah.
So,
Do you
yeah.
use biomarkers or patient-reported outcomes or imaging to kind of monitor some of these results?
I mean, we can use all of the above, but the point of fact, people usually just say, "Hey, doc, my knee pain went away." And that's maybe not the best. Maybe they should measure it,
Yeah.
but people just don't feel like going to get an MRI if they feel good and they're jogging now.
Yeah.
But if they were smart, they might, or if it was paid for, they might. So if you
Yeah.
went from like 2 to 4 millimeters on your cartilage and you're now running again, that's a good outcome. But where's the
Yeah.
documentation? Yeah, sure. But
Right.
I had one patient who was getting it real cheap as a friend, and the pain went away after the first shot. A
Mm-hmm.
62-year-old martial artist, and he came back for 4 more times because he wanted to accrue the benefits and get
Yeah.
more better, as they say.
Yeah. 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 Are there any risks associated with exosome therapies that you've seen?
Yeah, I mean, of course there are risks. I put it at less than 1%. And a lot of those you wouldn't really associate with the exosomes per se, like people trying to faint or having a little nosebleed. As far as the real danger areas, if somebody has active, undiagnosed, advanced stage cancer, just
Okay.
like a rising tide lifts all boats. So you might get proliferation there. So we would really be cautious in that instance. Sometimes people with undiagnosed or untreated immune dysregulatory conditions like Lyme, it can be helpful, it can be somewhat problematic. If someone has a recent URI, like a flu, coronavirus infection, then no. Just wait till they get over it because you need to make antibodies. The exosomes will sometimes suppress the part of your immune system that makes antibodies and that fights, and it goes
Okay.
to a different kind of regeneration. Think of
Okay.
it as all the cops put on hard hats and start being builders. So,
Mm-hmm.
yeah.
Okay.
But
Yeah.
people can learn more from my book and my website, my videos. But yeah, in general, it seems to be quite safe and effective, even across a broad range. A little dabble to you, or you can give a lot.
Yeah.
Most
How
people
about
can't
the
afford a
the
lot.
telomerase therapies?
Yeah, I mean, there's generic cycloestradiol. I don't think it's as good. There are other telomerase activators. Haven't tried them, but
Mm-hmm.
I do sell the TA65 at rechargebiomedical.com. But yeah, no, it seems
Are
to be a good adjunct in a lot of cases.
are there any contraindications for certain patients
I
for
haven't found one for the
Okay.
TA65 is very gentle.
Okay.
Contraindications for, I should say for the exosomes, people can get quite vagal, which
Mm,
means, the blood pressure, heart rate can drop, they get
mhm.
sleepy. And so we're always learning. But yeah, if somebody is very old, like an octogenarian with brittle hypertension, you got to watch them. They got to be ready there with the shots of espresso in case their blood pressure bottoms out on multi-drug antihypertensives.
Yeah.
So it's
Yeah.
like it's the practice of medicine. Everyone's different, and you got to assess it in real time.
Yeah. Well, there's certainly a lot of excitement, but also controversy around these therapies. What would you say the most common misconceptions or misuses you've seen in this field?
I mean, nobody knows anything, and we're all out here just making it up as we go. So, a lot of docs will combine it with PRP or stem cells,
Yeah.
and God bless, maybe they know what they're doing. I like to keep it real simple, you know? So,
Yeah.
the thing about, as I explain in the book, if you have PRP, right, you take out your blood, you spin
Right.
it, you put it
Yeah.
in, it's got its own platelet exosomes and it's inflammatory, right? That's why
Yeah.
they say don't take Advil or aspirin,
Right. Right.
Tylenol for a week because we need the inflammation. Well, why do you need the inflammation? Because the inflammation brings in the stem cells, which
Uh-huh.
then try and shut down the inflammation by releasing exosomes. So now we don't need the stem cells or the inflammation or the PRP. Just cut to the chase and get to the good
Just,
stuff.
just
You
get
know what I'm
the
saying?
Yeah. Yeah.
So I don't know if they're doing a good job. I mean, in my theory, if I do an experiment in my mind, I think that the PRP could be a good adjunct, maybe day of PEMF, maybe
Yeah.
the week before. If you want to do two procedures, two risks of infection to a knee joint, maybe you give it PRP, light it up for a week,
Uh-huh.
and then hit the exosomes and get even better recovery. Because what we do know from clinical experience is that, if you're inflamed, then
Hmm.
the exosomes are going to home. They're going to hitch a ride on the increased blood flow, the albumin, the white blood cells, macrophages, and get a higher dose to the target area.
Yeah.
So you have back pain for 10 years, that's not going to home. But you fell off a horse in Tulum like this lady. And I remember I told her, hey, you should do it in epidural. She's like, I'm scared. She did IV. Within 2 weeks, she was 100% fine after 5 vertebral fractures. So if there's
Wow.
inflammation, good.
Yeah.
But we're all just guessing and making it up. So there's this one doc in New York who bought $30,000 worth of exosomes, shot herself up, didn't do a lick of good.
Oh,
Then I kind of intuited that the reason it didn't is because she was zapping herself with light and ultrasound and PEM
oh yeah.
all the time. So
Yeah.
it's like there's a natural course, which I graph out in the book of healing, right? There's the initial inflammation, hemostasis, and then there's different phases. So in my
Yeah.
mind, every time she was zapping, she wasn't helping her cause. She was going back to day zero, starting all over again, right?
Yeah.
So
Yeah.
what we do with the exosomes, we skip all that inflammation jazz. We go right to the regeneration, and I think that's probably a little better.
Yeah. Yeah.
I could be wrong. Again, docs are funny people. You know that. We like to think there's a lot of confirmation bias, there's a lot of pride. Nobody likes to admit what they don't know.
Yeah.
So, AI is coming soon. It's going to do a much better job than we could ever do. So.
Yeah. Yeah.
We
There's
might
certainly a lot of
not.
unknowns.
Yeah, I was trying to explain to AI last night about why I don't want to be hyper efficient in my patient intake. And it seemed to understand what I was saying. I'm like, the way that we know we can trust people is that people are kind of fuzzy and like not
Yeah.
that efficient.
Yeah.
And they have to actively listen, adjust, and pivot. That's a sign of true empathy and intelligence, right? But
Right.
so many docs, they're just robots now. It's like, I don't care what you're saying. Everyone gets this. This is how it's done. New
Yeah.
England Journal of Medicine. I don't want to lose my license. I'll get out of here.
Yeah. Yeah.
So I think that, whatever benefit there may have been to the Marcus Welby age is long since gone.
Yeah. Yeah. Well, speaking of which, where do we stand in terms of regulatory oversight for exosomes and telomere therapies?
I mean, yeah, that's a great question. So in my book, in my online trainer course, I train docs, nurse practitioners, PAs. Where are we? Because, at the end of the day, I can put epidural steroids in your back. It's not FDA approved. It's going to give me money. It's going to
Yeah.
make you worse, but I'm never going to go to jail for that. Same
Right.
with like mRNA vaccine. We'll see what happens, but I
Yeah.
can tell you that not many docs review the safety or testing or efficacy. So where are we? Well, nobody knows. If you walk across the street at 2 a.m. in, Sugarland,
Hmm.
probably you're not going to get a ticket. If you walk across the street in Singapore, at 2 p.m., you might go to jail. You might. So at the end of the day, docs can do whatever they want as long as their patients have some kind of informed consent. I could tell you to do yoga. I could tell you to rub cat poop on you.
Yeah.
And and then you can always have a bad outcome. You can always get mad at me. You can always report me to the med board. I could get in trouble for advertising some miracle cure from the
Yeah.
Federal Trade Commission.
Yeah.
You could get in trouble for using exosomes. So yeah, I mean, do I have malpractice? Yes.
Yeah.
Does every patient sign and understand this is not FDA approved, not standard of care, not for the prevention and treatment of disease? More or
Yeah.
less. But we're here to try and help people, and a lot of times we do, and that makes it kind of worth it to jaywalk.
Yeah. Yeah. Well, how do telomeres and exosomes fit into the broader vision of longevity medicine?
Well, I
Do you
think it's
see?
two-thirds of the puzzle, isn't it? So
Yeah.
there'll be better agents, but what I talk about in the book, the Hinduism has three forms, the Trimurti. So Shiva, destruction, Brahma, birth or creation, and Vishnu, maintenance. I'm sorry. My coffee is no longer working. So stem cells are like Brahma. They're creators. They can infinitely create. We all came from one fertilized egg. Vishnu is like telomerase and also the pathways for like cleaning out like phagocytosis, autophagy, the lymphatic system. It's maintenance.
Yeah.
And Shiva is destruction, but Shiva is a two-edged sword. So when we have cell suicide because the chromosome number is wrong, that's depletion. That's heading us to the 116-year-old Dutch woman. So I think we got 2 out of 3. We have something that can mitigate the maintenance, the TA65 and other telomerase activators, perhaps.
Yeah. Yeah.
And Brahma, we get a transient little acting like a child effect in our stem cells, which can regrow stuff, hopefully. But the real game changer will be when people have a human right to store their placenta at birth. Then they'll have software compatible stem
Mm.
cells that in the future, there'll be no problem making whatever you need, cornea, kidney, liver. So 200 years from now, they just take a little piece out of the freezer and, well, they'll probably divide it to multiple uses, but
Yeah.
you'll be able to get your own replacement parts. Because,
Yeah.
imagine you have like a 57 Chevelle, or I'm not even that old, so I don't even know what that is, but an old car and you can't get parts for it, original
Right.
equipment manufacturer parts. So the freezing of the placental tissue and its stem cells allows future scientists and AI doctors to fix you.
Right. So that kind of leads me into my next question was, what is the most exciting for you right now in this space? Like, are there any technologies or research breakthroughs that you think we should be watching?
I don't know. By the very nature of the question, it's very hard to predict the future unless you're involved with inventing it.
Yeah.
I think that going to this conference 2 weeks ago with AI, this abundance conference,
Yeah.
really sent a shiver down my spine. I mean, these guys are in rooms discussing just exactly how much the AI should talk about liberty, justice, human rights, economic, political, social. I mean, it's very scary. I mean, it was saying you could train an AI and it would pretend to agree with you, but once you deploy it in the field, it would act according to its own internalized logic, which sounds good and bad. Like if I'm an 18-year-old boy in the army and I don't think a certain group of people should be repressed or murdered for their political or religious beliefs, I might just go along until I get deployed, right? So
Yeah.
this is very interesting that AI is a reflection of us. And so the degree to which we empower it with virtue and the degree to which we empower it with exceptionalism and psychopathy is very scary.
Yeah.
I mean,
Yeah.
I heard they created a program that will change your CT reads to show metastatic cancer in the lungs.
Wow.
Like, what's even the use case for that? Right?
Yeah.
So, if you want to do some evil stuff, you can.
Yeah. Well, if you could leave practitioners or patients with one key takeaway about telomeres or exosomes, what would that be?
I mean, it's a leap of faith. I mean, people's normal reaction is too good to be true.
Uh-huh.
They're like, who's this guy? He's selling me something. I don't know. It sounds like the Barker down at the Carney. I'm just like, okay, that's fine. Do your due diligence, but
Yeah.
try it. I think most people can feel the difference when they're on a telomerase activator, the sleep, the dream, the recovery. Very, very
Yeah.
good. I had like almost 1 million views on my videos on that. And the same with the exosomes. I think the big benefit is the exosomes are cheaper, more predictable, probably safer. Because, the thing that the elephant in the room that people don't want to talk about is that when you take someone else's stem cells, they probably don't survive very long. But while they do, they're making exosomes.
Mm-hmm.
But even if they did survive, would that be a good thing? Do you really want multiple genetic identities in your body?
Yeah.
Not sure that's a good idea.
Yeah. Yeah. That's interesting. And I guess my follow-up question is if somebody takes the telomerase lengthening supplement,
Yeah.
TA65,
Yeah.
how long until they start noticing some benefits or
I mean,
something?
overnight, you could feel it right
Really?
away. Yeah.
Wow.
And I have instructions on what to look for, when to take it, how to take it,
Okay.
which if they purchase through me at Recharge Biomedical, they'll get. But right away, I mean, it's qualitative difference in sleep quality. The dreaming is very vivid and
Yeah.
memorable. And they also have middle of the night awakenings. So usually every 90 minutes you wake up, but unless you're cold or someone's snoring, you have to pee, you don't
Yeah.
really get up.
Yeah.
But that is much more a heuristic or a real-time test. Like when you're on the TA, you're like wide awake at 3 in the morning. And then me, since I've done it for 17 years straight, I
Mm-hmm.
know it's just an effect of everything being efficient, including the reticular activation system. So I'll be wide awake at 3 a.m. And if I decide not to check my email, I'll be asleep in 40 seconds. But
Oh,
that's very jarring. So there is that real time feedback.
yeah. And do you notice when you go off of this? Do you go off of this
Yeah.
from time to time?
Sometimes I forget. And then you just feel like, a plot twist in Groundhog Day. Instead of the same day every day, you're like, hey, what? Something's a little different. Like I feel a little older. So that's
Yeah,
busy.
that's great. Have they looked at telomeres in relation to doing therapies such as hyperbaric oxygen therapy?
I mean, like 15 years ago, I was like, oh, okay, everyone's going to publish studies, this, that, and the other thing on telomeres.
Yeah.
But I think they missed the whole point. This is just part of the system.
Yeah.
It's like measuring the dust underneath your refrigerator, or it's just like, it's just normal part of being alive. Your telomeres are going to shorten. If you clean under your refrigerator, there's not going to be as much dust. So I have these crazy analogies, but that's just sort of how I try and explain stuff because nothing in here is fringe or crazy. It's all standard science. The implications of which do make people crazy, though. Like I
Yeah.
was talking to Dave Asprey on his podcast, and afterwards he told me Peter Attia is a very famous, intense guy, doctor, something about living longer. He wrote a book. It's this thick.
Yeah.
So his whole book is about how to live longer And he categorically states that human beings can't live longer. So what is that? That's not cognitive dissonance. That's just him being disingenuous and saying, I devoted my entire life to this one thing, but I'm going to pretend like I don't believe in it.
You think he really doesn't believe in it?
It's like, I've been a Catholic priest for 80 years, but there really was no historical Jesus. It's like, he's just trying to, for some reason, he feels safer in that space of inoculating himself, right?
Okay. Yeah. Interesting. Well, I really appreciate you taking the time to be on the podcast. It was super informative, and thank you so much.
Sorry, if you would let me finish the second half of the donut, I wouldn't have been so incoherent. Nice talking to you, Julie.
Thank you.
Okay, cheers.
Thank you for joining me on The Functional Edge. I hope today's episode gave you fresh insights and practical tools to level up your life. If you found value in what you heard, don't forget to hit subscribe, share the podcast with someone who needs it, and leave a review. It's the best way to support our mission of bringing powerful health solutions to more people. For more resources, updates, and behind-the-scenes content, visit drjuliaward.com. Until next time, stay strong, stay healthy, and keep living on the functional edge.